Here's an example of a quotient rule that's going to have a chain rule involved. So once again, the first thing I'm going to do is rewrite the radical with a rational exponent. So we'll end up with 2 over 4 minus x squared to the 1/2. Then if we write out what our quotient rule is, we're going to have the derivative with respect to x of the top, which is 2, times 4 minus x squared to the 1/2, minus the derivative with respect to x of 4 minus x squared to the 1/2. That's going to require a chain rule when we get there. We're going to multiply that by 2. And we're going to square everything that we have on the bottom here. So 4 minus x squared to the 1/2 times itself, if you will, or squared. So we're going to get 0 times 4 minus x squared to the 1/2. That's kind of nice. Then I'm going to note that in this function here, that u would be 4 minus x squared. That's a good choice for our inner function. And if I do that, then I'm going to subtract the derivative with respect to u of u to the 1/2 times the derivative with respect to x of 4 minus x squared, all times 2. And that's going to be divided by, when we square a square root, we just get whatever we started with. So we're just going to have 4 minus x squared in the bottom. So let's see, this is going to give us negative 1/2 u to the negative 1/2, right? The first part was 0, so I'm not writing any of that down. I can skip right past it. Times derivative of 4 minus x squared is a negative 2x times 2, all divided by 4 minus x squared. So that's going to be equal to, let's see, we've got a negative 1/2 and a negative 2, so that's a positive 1 times another 2, so we get 2. And we get x, and that's going to be times u to the negative 1/2, which is 4 minus x squared to the negative 1/2, all divided by 4 minus x squared. Now we can't cancel any of these 4 minus x squareds top to bottom because they don't have the same sign, so we have to be a little bit careful here. So what I'm going to do, a nice little trick I like to use, is I look through the numerator, and if there's multiple terms, I look at everything that has a negative exponent on it that has the same base. And what I'm looking for is the most negative exponent. And then I'm going to multiply top and bottom by exactly that to the positive version of that exponent. So in this case, my exponent is negative 1/2. It's the only one I have to worry about. But maybe sometimes you'll have a negative 1/2 here, and you'll have another term in front of it that has a negative 3/2. Since negative 3/2 is more negative, you'd use 4 minus x squared to the positive 3/2 here. We're trying to get a positive exponent that's just large enough to wipe out the most negative exponent in the top. Since we're multiplying, we'll make sure our fraction is equal to 1. That is, I'll put 4 minus x squared to the 1/2 over itself. So all of that is going to be equal to 2x over 4 minus x squared to the 3/2 power. When we multiply 4 minus x squared to the negative 1/2 by 4 minus x squared to the positive 1/2, these two exponents add to 0. Anything to the 0 power is 1, so these essentially just kind of disappear. 1 times 2x is just 2x, that's all that's left there. And in the bottom, we can think of the first 4 minus x squared as being to the first power. 1 is the same thing as 2 over 2. 2 over 2 plus 1 over 2 is 3 over 2. And that's how we get to that derivative.